So now what we're going to do is look at the scenario where we're at the equivalence point. And the way we know we're at equivalence point is we would take the liters of our acid, multiply it by the concentration of the acid, and we get 0.006 moles of acid. We do the same thing for the base. And again, if you're doing this problem in multiple steps, that first step you would have already had the value. You don't have to calculate it every time. But the second one we have to calculate each time because it's the one that's changing. And what we get is 0.006 moles of our base, OH minus. So now we're at the point where the two equal each other. So what we're doing is this base is going to completely remove the HA to make A minus. So now we're actually starting with A minus, and we're reacting that with water to get to HA and OH minus. So what happened here is we switched. We went from doing Ka, the acid equilibrium, to now the base equilibrium, the Kb. We are not starting with any OH minus because it was all consumed to make our A minus initially. So what's happening here is we're actually starting with, instead of the number of moles of our HA, we're actually starting with that many moles of our A minus. But keep in mind, what happened here was we added volume. So we have to find our concentration here. You need concentration now because we're not doing Henderson-Hasselbalch. So 0.06 moles divided by the total volume, which is going to be 100 milliliters, or 0.1 liters, because we're doing concentration, it has to be in liters. What we get is 0.06 molar. So that is the concentration of the A minus we're starting with. And again, we got there by taking the moles of HA, knowing that it is converted to A minus, and dividing by the total volume of the solution. So I'm going to go ahead and plug that into my rice table here. We have 0.06. We're starting with 0 and 0. We're subtracting x on the left, adding it on the right. And we get 0.06 minus x, x, and x. Again, this is going to be the same thing as no KOH added. It is just our K value, in this case it's KB, equals x squared over the initial concentration. We can omit the minus x because we're assuming it is negligible. And so that means it's not going to affect our overall value. We can just drop it from the equation. The problem here is we need KB, but we're given Ka. So what we need to do is we need to convert Ka to Kb, and remember that 1 times 10 to the negative 14th is equal to Ka times Kb. So you just need to divide 1 times 10 to the negative 14th by your Ka to get Kb. And we're going to go ahead and do that calculation, and I'm going to erase all this so we have room to do the math to solve for Kb. And what we get is Kb equals 1.02 times 10 to the negative 10th. And that's going to equal, again, x squared over our concentration, which is 0.06 molar. So doing the math, we multiply Kb times 0.06, and then we take the square root of that, and what we get is x equals 2.47 times 10 to the negative 6th. Now that is my OH minus concentration. What I need to do is take the negative log of that, but it's going to be the negative log of OH minus, which is actually equal to POH. So when I take the negative log of that value, so negative log of 2.47 times 10 to the negative sixth, I get 5.6, 5.61. But that is the POH. If I want the pH, I need to subtract 14 minus 5.61. And what I get is 8.39. So the pH is actually 8.39. And actually, let me write that out better so we can see it. Using our calculation of POH, again, we get pH plus POH equals 14. We found our POH to be 5.61. We just do the subtraction to get pH equals 8.39. And this makes sense because it's greater than 7. When we start with a weak acid and titrate it with a strong base, at the equivalence point, we would expect the solution to be basic, greater than 8.39. If you started with a weak base and added a strong acid, it would be less than 7. So anyway, that is how we find the pH at the equivalence point. You have to switch the K value. So originally we were doing Ka up until the equivalence point. At the equivalence point, now we're looking at Kb. And then the next step would be if we add excess base. And that's going to be the next video.